When we think about threats to our environment, we tend to picture cars, smokestacks, not our dinner. But the truth is, our need for food poses one of the greatest dangers to our planet. This quote from Jonathan Foley, a fellow environmentalist, has stuck with me over the years. Why is food a threat? That's because in order to produce food to feed our global population, more than 70% of our non-renewable water, defined as water that cannot be replenished within our lifespan, has to be pumped up for agricultural irrigation. Recovery for reuse is challenging, and the end outcome is increasing water scarcity. So how do we achieve food security without compromising our water supply? We know that many countries in the arid regions have started to investigate the use of treated wastewater for agricultural irrigation. However, the existing treatment processes are energy intensive and relies heavily on the use of chemical disinfectants that can potentially endanger us during the reuse itself. This predicament has motivated us to explore alternative treatment technologies, particularly those that move away from the current energy-intensive ones. We also aim to explore alternative disinfection processes that do not require the use of chemicals. We have developed the anaerobic membrane bioreactor and the UV-based disinfection process for this particular purpose. What is this innovation? Anaerobic membrane bioreactor makes use of microorganisms that thrive in oxygen-free environments to convert organic carbon into methane, an energy source. This energy can then be used to push water through membrane with pore sizes smaller than that of bacteria. This means bacteria are removed from the wastewater, allowing us to clean the water with minimal energy costs. The water that's coming out from anaerobic membrane bioreactor is clear water, which makes it particularly suited for UV disinfection. UV does not require the addition of any chemicals, and through our research, we have found that it is highly efficient, able to inactivate up to 99.999% of bacteria within a very short time of 30 minutes. However, one problem that we face is the gradual buildup of bacteria and its gooey materials on the anaerobic membrane. This means more energy has to be used to push water through the membrane, counteracting the benefits we can derive from anaerobic membrane bioreactor. To solve this issue, we collaborate with material scientists at KAUST to develop novel membranes that can hinder the buildup. We have evaluated these membranes to ensure their performances, but what we also found is that bacteria are highly resilient and almost impossible to fully eradicate no matter how good the membranes are. We therefore postulate an additional question. What if we can make use of this buildup to our advantage? Specifically, can we improve the removal efficiency of bacterial contaminants using both the buildup and the membrane? We found that if we allow the buildup to grow to an optimal thickness, we could indeed achieve a much better removal efficiency than the clean membranes alone. But the genes, which are way much smaller than that of bacteria, can still pass through both the buildup and the membrane. This is when the UV disinfection can come into play. Not only is the UV able to inactivate bacteria, it can also damage the genes that pass through. This means the damaged genes can no longer be expressed into any meaningful gene products, and we are obtaining clean water that is safe for reuse. While new technologies are being developed on a daily basis, we are still stuck with the existing wastewater treatment process that has been developed since the past century. Perhaps the biggest obstacle in revamping the way we want to treat and manage our wastewater lies in introducing new technologies to a sector that is traditionally conservative, one whose common belief is, if it works, why bother to change? Today, we have the opportunity to come together to think about how we should redesign our future wastewater treatment plant. It is in my opinion that first, we need to be more open-minded towards new technologies that have demonstrated robust evidence of it being safe and sustainable. Second, we need to change our current business and governance models to create profitable markets for resources that can be recovered from wastewater. Third, different stakeholders need to come together to share information. Scientists need to raise red flags about new contaminants in the wastewater. Engineers need to evaluate the technologies to make sure they are able to remove these contaminants. And regulators need to update their policies to better protect public health. In planning for our future wastewater treatment plants, it is vitally important to move away from the current unsustainable practices to practices that are safe and sustainable, recovering as much resources as we can from the wastewater without compromising water quality and public health. In fact, should we still be calling our wastewater waste water when there's so much resources we can recover from it? Thank you.